your new project. So it is a Kaggle competition about machine learning, and it is about predicting the stock market. So you get 5 days of data. Apparently, the day before, 2 days before, the day before, the day of, the day after, and 2 days after. And the idea is for a specific stock, they'll for the testing cases, they'll give you the day before, 2 days before, and they want you to predict that day, the day after, and 2 days after that. So it's a straight prediction competition, and although it's a bit more complicated, it will be way more explicit of a description of a project than any other projects you've gotten, right? So, has anyone done a Kaggle competition before? Okay. So one of them was the prostate or prediction competition, I should call it, right? So these are becoming a lot more popular, and I think, although this is a complicated kind of format, I think this is very, very relevant to if you want to become a data scientist. People give you stuff like this and say, I'll give you a weekend, return this to me, this is a coding exercise, and you tell me what you do. You tell me what you make. This is, in some respects, some of the truest to form kind of interview things you would get to try to be a data scientist, in my opinion. Okay, so there's a description of the data, or a description of the problem, which is not good. The evaluation. So it tells you how it actually evaluates your prediction. So I know Jeff talked about mean squared error, root mean squared error, and they're not doing that here. They're using weighted mean absolute error, right? Which is like mean squared error in some respects, right? It's a deviance from your y minus y hat, but you don't square it, and you also have weights. I don't actually know what those weights are, so like you, I found out about this like a half hour ago because I wanted to be able to talk about this kind of stuff because I was going to talk about way other things. So today I'm going to be talking about predominantly two things, not necessarily this competition, the cluster and prediction algorithms. So who does not have a cluster account? Go to Jong right now. No, I mean go to Jong, get an account set up right now. I don't think yeah. So go see if he's in his office, because I will record this, but you need an account by today, in my opinion. You need to be able to get on there, and I'm going to talk about how to make things easier for students to kind of get on. Okay, so how do most of you log on to the cluster? Excuse me? So, okay. So a lot of you probably, right, SSH is probably the predominant way to mostly do it. Some of the Windows people, it's a little bit. You say SSH, your account, something like that. You say that. Sometimes they ask you for a password. Sometimes they ask you for some other secondary thing. So who has passwordless login set up? Okay. So right now, do you?
I don't need a password.
You do not need. You can just say login, and then it'll log in to this. In your terminal, you say that, and you're on the cluster. Okay, so you have passwordless logins. Okay, great. So that's step one, in my opinion, because I think logging on and off the cluster, having to type your password every time, is actually a burden. Because the way at least I am going to suggest to kind of use the cluster, you might be using multiple windows at the same time. You're going to be submitting jobs. So, second thing, of those who has anyone not submitted a job on the cluster? Okay, so let's talk about. Excuse me. I'll talk about this alias in a minute. This QR. All this does is it logs me onto the cluster, and it logs me onto a node. Okay? that make sense to everyone? Right, so I'm not on Gypsy, I'm on a compute node, not, right, so Gypsy is the main computer everybody uses to log in. A compute node is where you can actually run R and do stuff. Okay? Not there? Okay. Okay. So, again, so there's Gypsy, which is the main computer that everyone uses to log in. Compute nodes where you actually do some actual analysis or work like that. Okay. Now, to submit a job, right, usually you have to use qsub, right, which is submitting a job to the queue, right, or the line, right? And most times you say qsub cwd for current working directory, right? If everybody knows exactly what I'm talking about, that's fine. I'm just going to keep go over something like that. But I'm going to also talk about things to make your workflow faster. Okay? So
do you have to be on a node to do that, to do qsub?
No, you do not. But I, as a recommendation, I never sign into Gypsy. I only sign on to nodes. So qr, no. Okay, why is this on a discuss? Okay, so your homework for me is to read this. So this is one of Leo's submissions, one of his blog posts about how to log onto the cluster, request the node, and change your project directory in a single command. So, like I said before, when I'm in, so right here, I am in my computer, right? This terminal is pointing to my machine, and I say qr. qr is a thing is a command on my machine that will log me onto Gypsy, log me onto a node, right? So that takes it away. So one, that's called an alias, right? So this maps to some, you can think of it as a function, but just a series of bash commands. It says like, you don't need to know necessarily all these terms. You just have to know kind of what it does. This will log me in, log me onto a compute node. So like I can say like R now because I'm on a compute node. If I log into Gypsy, which I still have mapped to an alias called Enigma, and I try to say R, it says you are running on a login node, force quitting, right? Which is a safeguard from our department so that you don't start like, see, one of those machines in there is like the master machine that I log into, you log into, you log into, you log into. So if you started running something super computationally intense on there, you could potentially lock out every single person from logging in. So they don't let you do that kind of stuff. So they always suggest, I don't know who've had the Mark Miller training, but he always suggests then logging in, right? So you usually say qrsh, right? That's usually what you say from Gypsy, and that will allow you to log on to a node. But although it might seem a little extreme, but I think having to type in 2 commands versus 1 is actually burdensome if you start using the cluster a lot. And why am I talking about all this? If you're doing a competition like a Kaggle competition, and you have a computing cluster at your disposal, you should almost never be working on your local machine, in my opinion. Because a lot of these things, maybe like interacting and exploring the data is one thing, but like a lot of these competitions, the data is huge. So you can't even, like, one, storing it on your local machine might not even be possible, let alone memory. Like actually downloading it all to one machine might not even be possible. So you'd want it somewhere on there, which has terabytes and terabytes of I think we have a couple petabytes of hard drive space there. You have at max like a terabyte or 2, right? This data set's not that big, right? If you actually look at the data, you want to get on there, sample submission, training and test, it's like 70 meg. So uncompressed, like you're under like 200 megs, which is easy to store, easy to do stuff with. the testing data in some of these instances might not be that important, or it might not be that small, so it is relevant. But at the end of the day, if you want to be a data scientist, in my opinion, you have to be able to work on a computing cluster. Like, unless you have this beast of a machine. So, like, some people here have, like, desktops that have maybe 5 terabytes of hard drive space and maybe, like, 60 to 100 megs of RAM, or 100 gigs of RAM, right? Which is nice, but it's irrelevant because once you hit that limit, you either have to buy a bigger computer or get smarter. Getting smarter takes a lot of time. It's very costly. I just rather buy bigger computers, but we already have really a big enough computer that'll hold almost like 100% of my crazy needs. Okay? So if you're going to use this project, I would say the computing cluster, this is a great example when to start learning how to use it, especially if you're working in some respects together. I don't know what the format's going to be, but that's why I'm talking about the cluster today. Okay, so I'm also going to send you a couple aliases, and I'll tell you what that means in a minute. So, going back to Bash. So when I say qr, right, my computer knows to call a certain set of commands that'll log me onto the cluster and all that kind of stuff. So that is called an alias. So I might be able to go alias list, alias qr. So if you say alias, and you can think of it in some respects as a shortcut, but if you say alias and then the alias that you're looking for, it'll tell you how it's defined. Okay? It seems very complicated. Again, you don't need to know exactly what it's doing. All it's doing is saying, log me onto to Gypsy, log me onto a node. Now, where is this thing stored? So, of those on a Unix system, I don't necessarily know how to use this with PuTTY, but there is almost everyone, or you should have either a .bash profile or a .bash RC. So, I want everyone, at least if they have a terminal, open a terminal and do open ~bash profile. And see what happens. Yep. I'm going to move it over really quickly. Give me 1 second so I can show you what mine is. I think make it a little bit smaller. .bash underscore profile. So tilde just means your home directory. The dot just implies it's what's called a hidden file. Right? So if I went to my local directory and you don't have the settings in a certain way where you can see these files, right? If you open your home directory, you probably have a lot fewer things in here. Even though I have like a lot of things anyway, I think the idea, or if you don't have hidden files shown, these dot files don't exist. So that's why opening it from the terminal is what I suggest, because some people, depending on your settings, might not be able to see these dot files. Okay, so what happened? What happened when you ran this? Somebody tell me anything in their bash profile. Is there anything? So did you open here? I'm gonna look at you. So that's. So you have aliases for the cluster already? No. So you have your bash RC.
I have everything in bash RC.
Okay. All right. So you can already log into the cluster. So can you pull up your command that will one command that will log you into the cluster and log you onto a node? Yep. That's what it looks like. Alright, what does yours look like? Alright, that's yours. Alrighty. Yeah.
So if you type in alias, is that supposed to log you in?
No, alias is a bash command that's just saying like define a shortcut. So can you open up your bash profile? No, this is nothing on your the cluster. This is just on your machine. So open space. You have to put a space tilde bash underscore. Open. No. Alright, so open up your. So what do you got? You got something in there. Okay, so you have an alias to the cluster. Great. Yeah. Then just open yours on the cluster that you know, using VI. Okay. VI tilde bash profile. Okay. So this is a bash profile on my machine. So there's a whole bunch of crap to find because I do a lot of things with it. But I want to. So I want to just talk about two separate things. Aliases are one thing. They're like shortcuts. And then you can define what are called variables. So for example, if I never want to type in my username at gypsy, either 01 or 02, it doesn't really matter, .jhsph.edu, I just called this thing called jinig, which stands for me, John Enigma, right? Because the cluster used to be called Enigma. So that's why I called it jinig. So the way you reference variables in bash, echo just means print, is a $sign. So variables are referenced with $sign. Aliases are just like shortcuts. You just type them in. Okay. Don't worry about, let me see. So, what I will do is I will adapt my aliases, which I've created a couple. Two that are actually just, I'm going to adapt two of them with respect to what Leo had in his blog post. So QR, he pretty much has it, right? Log on. The other one, is this command called qrgig. qrgig stands for I want to log into a node and I want to request specific memory limits. Right? So QR, right, the way at least Leo has defined it in his blog post, will just log you in with whatever default you have. Okay? Log you into a node with default, like maybe 2 gigs of memory, 3 gigs of memory, something like that. Okay? But if I want to put in different memory limits, that's why I made this qrgig. So qrgig 3031. So that will log me in to a node with 30 gigs of memory, 31 gigs of hard memory. So if I go over 31, it'll either fail or tell me I've run out of memory, but I've requested 30. Okay? So of those who have who have a cluster account, Mark will tell you kind of about these if you haven't. Memfree and HVMem, right? So memfree says how much memory needs to be free. HVMem is kind of the hard stop. If you go over that, kill the job. Okay? So qrgig 3031 will put in 30 for memfree, 31 for HVMem, and then you could put other things that would come under the L specification. So, for example, I want to go on the interactive node. This is very important if you, for example, chew up 200, like you already have your cluster account maxed out and you want to get onto a node and you want to actually be able to still do stuff interactively on the cluster. The interactive node, let me make this actually. QRS requests were 30 gigs of mem free, 31 gigs hard stop, and now I'm going to go in the interactive node. So that will, even if I have 200 slots taken up by my account, I can still get on the interactive node. So this also allows me to specify other things than memory free and HVMem so that I can log in. Does that make sense? So QR will just log me in with my defaults, log me onto a node. qrgig, I specify the memory that I want, and I can put other options in there. And I will send you a text file with these in there. Okay? All right. Now, what are some other useful? So, okay, I told you before about variables. So what is the bash profile? Let's kind of step back and talk about that. What is that? So when you actually say like new terminal screen, right? What that will actually do is load your bash profile. So all the commands, everything in here, every single thing on this left-hand side of the screen will get run every time you open up a new tab in your terminal. Does that make sense? So it's kind of like, it's just like starting up your startup stuff, right? For when you want things to run for bash. Okay? So right now we haven't talked about really anything about the cluster, but the cluster is a Linux environment in the sense it has a bash profile on the cluster as well. Okay? So I'm going to log into the cluster and I'm going to show you what that looks like. No. Sorry, I just didn't know what I wanted to do there. So, because you can't just say open on the cluster necessarily, so I use VI. If you want to know about VI in the command, ask Steven. He knows everything about VI. So it's just a text editor. Okay? Yes. So Hang 2. Ask you guys, don't ask me.
What was the command?
VI. So I'm on a cluster node. I want to edit my bash profile on the cluster. Or bash R. We're not even going to get into bash RC, right? It's for those who know what bash RC is, this is kind of irrelevant. So now, when you guys submit a job on the cluster, right? Usually, the way it goes is you have, and let's say you're not doing anything bash. Let's say you're doing stuff in R, which most of you are. So you have an R script, right? Or .r file. This is going to be a little confusing. Right? You have a .r file. So, of those who've submitted a job on the cluster, how do you get this R file to run? So you have to qsub it. Sorry, say that again?
The .xh file.
So .h. So you have to say like, so let's call this x.r, right? Usually you call something like x.sh, right? Which is fine. So, but that means you have to create a file on your own, right? So you have to make an R file that either does something like this, so it'll say like R script. So this is a specific command, x.r, with some options. Or you can also do R -- node -- save arrow x.r. So those are two different ways that you would submit an R job. So R -- no save or R script.r. Now, for most purposes, these are equivalent. They're not exactly equivalent though. So two big differences. If you use command args, you have to use this. Okay? And what I mean by that is sometimes you want to specify a job in bash, in this, where you actually want to pass other things into R. Right? You want to say like, I want to set whatever parameter to be like 5. And so you want to be like blah, 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 blah. A is 5. Does that make sense? You want to pass a command line argument, command args, to R. So that you can use it in your R script. If you want to do that, you have to use this R script command. Now, the other thing about that is you may have to include the library methods, the methods package into that. Because if you Google rscript methods, it'll say something like, so sometimes you might get things fail, and it'd be like, not unknown method for blah, 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 blah. And so rscript, in the nitty-gritty, help file, it says that the default for rscript omits methods as it takes about 60% of the startup time. So rscript can be faster. Faster startup. Okay? Now, the other thing about it, nothing will get printed. So when so you submitted this. There's always two things that come out: a .o file and a .e file. A .o like 7624, and then a .e 7624. This stands for an output file. This stands for an error file. So in general, startup messages, warnings, that kind of stuff from R will go here. Also, obviously, errors. And pretty much your output will come here. Not like plots, but like if you print something, it'll go there. Now with rscript, by default, it doesn't print a lot of stuff. It won't like print out like all the code, for example. If you use rnosave, it'll print out the code and the output into that O file. Why do you care? Things fail all the time, and you want to know where. And sometimes it's not always easy to figure out with this. So I use this method as my default unless I'm passing command line arguments. Does that make sense? Unless I've set it up that, like, I pass something in bash, it goes into R, and I need to use that in R. If I don't have that, I use this. Does that make sense for the most part? Now, these things that I'm showing up here, where did they go? Oh, these are two simple functions that I created so that you don't have to make the .sh file. Okay, so again, when you qsub, you only qsub sh files for the most part, right? At least when you're doing R specifically, right? And those sh files say one of these two things. Maybe you have other options. Making one of them for every R script that you ever want to run is another hurdle that seems irrelevant to me, right? So these functions, for example, rbatch, which is so there's rbatch and rnosave. Rnosave just passes in the second part, the second type of running an R script. Rbatch runs the actual R script version, right? So again, these are two ways to call an R script in bash. The rnosave command will do it this way. The rbatch command will do it that way. So what I'm going to do is copy these, send these to you, and say like cluster bash profile, and it'll be like local bash profile for things that you should have locally, things you should have on the cluster. Okay, so that will hopefully reduce the crap in your folders, right? You don't necessarily need like a .r file, a .sh file, a .r file, a .sh file, so on and so forth for every single R script you wanna actually run. And by default, I have the current working directory kind of as the default there, because I usually am in a folder and I say qsub or I say run this file versus like giving it an entire full absolute path, right? So cwd will say like run it in here. These files should be outputted in this directory versus somewhere else. So let me show you a good example of an alias. So I almost never use qsub. I use qcwd, which is just shorthand for running qsub with the default current working directory. Right? Again, these are not like super smart things to do, but I think they can get you in the habit, or they can just make you somewhat faster in doing things. I would say these two are almost absolutely necessary if you're doing R on the cluster. Like some sort of function that will take an R script, wrap a sh file around it, run that sh file, and keep going. Okay. I know this is like highly technical, super boring stuff for the most part. So that's why, what are the questions? Because I know there are some. Because I had a lot kind of going on this. But again, you don't necessarily need to know what exactly all these commands are doing. You just need to know, for example, that when you want to submit a job, let me show you a no save. Right. So for example, I wanted to submit a job. The R file is called final predictor cutoff volumes native, right? I named the job, so -n. So I would almost always name your jobs as well, right? So that like it's not like why name your jobs? So if you don't name your jobs and you like submitted x.sh, okay? If you don't name your job, the outputs will be x.sh.o/6, x.sh.e, right? I want to look at these, and most of the time I just want to trash them. But what if there's like 100 of these that come out? And we'll talk about array jobs in a second. What if there's like 100 of them? Many times I will unintelligibly say like rm x.sh star or x.star because I'm going too quick, I'm not thinking a lot. So what's that going to do? That's going to delete these for sure. That's also going to delete my x.r, my x.sh. So normally I would name that function, I would name that job to be like, you know, what are we doing here? Let's just say like random forest. I'll call it like forest. Now I'll usually do it in all caps so that I can find it easier on like, you know, the command line. If I want to say remove capital F, capital O, I rarely name files with all caps. So I can find this, I can say RM, F, O, I hit tab, it completes, it goes to forest.star. Now I know the way I name my functions, nothing's going to be called all caps forest other than the stuff that comes out from the job. So for example, I don't know why I'm using that example, fcut vols. That's when I name it. So what will come out is fcut vols dot o some ID dot e some ID. That ID is the identifier for the job on the cluster. So I can look at them easier. It's just naming them is a good practice because when you have to kill a job, I don't think I have any jobs running right now. But if you want to kill a job and you say qdel, right? So qstat will have you listing all the jobs. Oh my god, I have so many of them. So let's say, actually here's one. Say I want to log out of all of my sessions. So if I want to log out of this one, and I haven't named it, I have to say qdel the name, or sorry, the ID number, right? But what if I want to log out of all of them? Because they're technically named qrlogin, it actually will stop all of those jobs, right? So this is a named job. You can say qdel either on the ID, which is cumbersome and you have to do it multiple times, or you say qdel of the name of the job. So the example I gave before, you would say qdel fcut vols, right? In this case, it doesn't exist, but that would be how you could kill the job without having to do qstat, finding the number, and then killing it that way. Okay, where were we? Oh, man, I was like looking at stuff. Well, I killed that job, so it was like not too happy with me. All right. So the other thing is, why do you sometimes want to make these variables? Why make, I showed you the one that Jay and Nig one. It's like, well, I don't mind typing that out. It's like, well, you can type it. I hate typing things out. So I usually also make variables, right? When you say something equals something, that's an environment variable. And what I usually do is I set directories that I go to frequently, like directories where the data is, or where I'm doing analysis or something like that. I set them up to have shorthand commands. So, for example, dex. Dex is a area on the cluster where I have stroke data. So I say cd $dex, and that brings me to the right directory because I find this variable in the environment. Right? I mean, yeah, like, who doesn't love going to C, Dexter, dis2, smart, like, I just don't have time. I don't have the time or the brain power to remember exactly where everything is. I want to remember where it is once, and I want to remember an alias that I created, or, sorry, not an alias, a variable that I created that I can reference easily. But the fun thing about that is you can do other things. So you can say, I want to go to dex / and then you hit tab, and then it'll autocomplete. So let me just do that again. So cd dex, I do a /, and then I hit tab, and it autocompletes to where I am. And then I can do like double tabs, hit tab twice, and it'll show me all the directories that are in there. Right? So these things just make you faster. I'm going on the cluster. The other thing is, whatever variables you make on the cluster, I would suggest making them on your local as well. Now, what I mean is, when I make a dex environment variable here, I make one on my local bash profile. Now, why do I do that? I do that because when I want to sync things up and down, when I want to throw files somewhere, I, again, don't remember where they are generally, but I do remember the variable I set it to. So for example, whatever, pto. I don't even know what this is, but it does. Sure, program.pdf. So I'm going to rsync program.pdf, and I want to send it to something on the cluster. So the way dex. Okay. So what is actually going on here? rsync is a command that will send stuff to the cluster. It's a little bit different than SCP. SCP is a secure copying protocol, right? So SCP means copy, or secure copy, really, right? That'll take something and throw it to another location, whether that's local or on a server. In this case, it's on a server. rsync is a little bit different. It'll look at the file you're trying to send. It'll look at the file that's on there already, if there is one. If there's not, it'll copy it. If there is a file already up there, it'll look, say, are these the same file? If so, I'm going to skip it. I don't have to waste all that time, all that bandwidth to copy things. So I use rsync as, in general, to sync things like scripts that I have locally with the cluster. Okay? Now we already know what J, sorry, this is D and Nig, but J and Nig was, right? Remember? It's just that login. And we know, and I have dex set locally. So what that really means is rsync program.pdf, this colon, when you use rsync or SCP, you have the login information, which is your username, @ the server. In this case, that's my login to the cluster. I'm logging into Gypsy01. And I want to say, the colon means where on the server do you want to place this thing. The colon says now you specify the directory. So also, if you're syncing stuff up and down a lot, use Gypsy 03. Hold on. So, sorry, let me step back. What will this do? This will say, take program PDF, go to the cluster, go to this spot, and put it there. Okay? Is this command clear? So now, let me go to the cluster. There's a program.pdf. Okay? I'm on the cluster. That came from my local machine. So is this command clear? And the shorthand I did for that was this. JDinig pretty much has all this information in there. Dex, the $sign, that variable has all that information. So that's why it's important that if you make a variable on the cluster for a directory that you go to a lot or you use a lot, it's important to have that locally as well, because when you want to put stuff up to the cluster, when you want to sync things up, you usually want to reference that directory.
But both of those are on the cluster?
So this is my local machine. Dropbox is me.
So it's sync.
It's saying our sync program PDF is not on the cluster. This is something on my local machine.
But those. Sorry, I think I'm confused about what's.
What variable? Where are these defined?
Yeah. Well, just like even just written out.
Okay. So this is saying rsync, give it a list of files,
Yeah.
then tell it where to put them. Okay.
And is that one location or is that two locations?
This is one location.
Oh.
This is saying this folder on this server.
Oh.
And to get onto this server, you have to log in.
Okay. I was reading that the colon is like two locations.
No,
Like
the
you're
colon
syncing
specifies on this the file location on this server.
So it's like the server and then the file path.
Exactly.
So that's for sharing files, also using that.
So how do you get things onto the cluster?
So I mean, what's the use for this comment for sharing program PDF file on the server?
So like I'll write like a function or a program, like a .r file, locally, because I'll maybe interact. So but you got to get that R file up to the cluster to run. Like this current R file right here.
But that is a PDF file.
That was a PDF, but like maybe you want to data. What about data? Like let's say you had like an RDA that you want to send up to the cluster and work on it up there.
But who can access that file?
That depends on where you put it. So you're the creator, so you can access it. But you, so like, let's do that again. So ls-l for the long version program. So, for those who don't know how to read ls stuff, this should be a quick tutorial. So this is the user that owns this thing. This is the group that user is in. And that's, so user group, and when it was created, how big it is. This is talking about the specifications for the ownership. So it's like, when there's no dash, here, let me just do one of both. So when the first column of these things stands for, is it a directory or not? If it's a dash, it's a file. If it's D, it's a directory. Okay? The first three letters stand for the user, J. Michelle, me. What capabilities, what things can it do? I can read it, I can write it, and then there's a dash. So the three things go read, write, execute. So I can't actually execute this file. So if I say something like dash program.p program, let me see. What happened there? Did I delete it? Say permission denied. You're not allowed to execute this PDF. Executing a PDF doesn't make much sense anyway, but if it was like a .sh file, like a script, if you don't have an X there, it means you cannot execute it. Okay? But if I say chmod plus x, I think it's u, excuse me? So you can add these things. So chmod, I'm not going to go into this. This is like pretty dense and like, but the idea is I want to at least show you how to read it. So 3 first letters are for the user. The 3 next letters are for the group. So the group, those people that are in stroke _ C _ ident can read it. They can't write it. They can't write over it. And they can't execute it. And then the last 3 are for guests. So for example, if you aren't in this group, you can only read it. So for example, S, just don't even worry about S. It's just, it's kind of like it's kind of like, I don't even know. I forget what the S even stands for. Don't worry about that one. But chmod will allow you to change the permissions of a file, right? In this case, I want to say to the user, I want to add executable capabilities. Now I said minus, I took it away. Went away. It's like magic. No. All right. So, take-home messages. Read Leo's post, which I'll send you an email about. That will allow you to, from your machine, say, log me onto it, Gypsy, sign me onto a node. Okay? I will send you a document of things to copy into your local bash profile. Okay? And those will be, for example, the qrgig function, which will allow you to log on, request specific amounts of memory, okay, versus just logging on. I will also send you things to copy and paste in your bash profile. And now, for the last but not least, how to copy things in VI, how to exit VI. Because as a new user of VI, you might not. It's not very clear. Okay, so VI -bash profile. Ugh, it means it's already open. Oh, I should have just talked about that. Okay, here it is. I'm in it. I'm starting to type. When you first log in, when you first open it up, you guys might be better at like explaining this, but I'll give you the long and short things that I know. So if you edit something and you want to exit, so first off, you exit by hitting escape : so escape : Q. That means quit. Now, if you've edited the document and not saved it, it'll yell at you. Okay? You say escape : Q ! That means quit and discard any changes I've made. So that, all this garbage up here, I don't want that there, so it'll quit. So if you open up a document and type the letter I, you'll see in the bottom left-hand corner, their insert is activated, so you can paste things in here. Right? I just did Command V, right? I pasted something in there. I don't want that to show up in there. But let's say I want to insert just a space. Like, I think that looks better than one space. And I want to actually save it. So you can say escape. Whoa, what just happened? Escape escape : W. You see in the left-hand corner, that's where you can see what's going on. That wrote it. Right, so escape : W will write the file. Okay, it'll actually save your changes. So WQ together will write it, will save your changes and quit. So what I'm saying is when I give you stuff to copy and paste into your bash profile, type VI here, type I, the insert thing should come up. You can copy, you can paste, hit escape, hit colon, WQ, and it's in there forever. There are a lot more commands you can do with VI. There's a lot of stuff you can do with it. But for right now, all we're using it for is a very, very, very simple text editor. We could have also, we're not going to talk about cat or how to do it command way, but whatever. So now, if you perform those operations, and I'll send you the QR, these two, the R no save and the R batch. If you perform those operations, what you should be able to do after that is to execute an R file. It'll Q sub it, right? It'll actually submit a job with automatically generating an SH file, and you can do it and specify other memory requirements, stuff like that. Don't worry about what this stuff means just yet. But the idea is R no save will send this will make a quick wrapper.sh file for this function, so you don't have to do it yourself. This will name it. This will specify the memory that's needed, and it will submit the job for you, and then it will trash that .sh file, so you don't have to clutter your directories with multiple .sh files. Okay, and again, this right here is a little bit different than R batch, but for the most part, unless you're doing command line arguments, which if you're getting used to R, you probably aren't. It's just a little bit different, but R no save will have more output by default, but it won't allow you to do command line arguments, but it will load the methods package. And it's not. I say that, and you're like, well, what's the methods package? I never load that anyway. When you start up R, by default, it is loaded. So there are some times where a script may error, and what you just have to do is put library methods in there and rerun it. So, for example, in this machine learning problem, let's say you wanted to do something with, I want to run some random for something. It takes like an hour to run. Don't run that locally. Just don't. Like, write the code that will read in the data. Write the code that'll do the analysis. Write the code that'll save the output. And then go to the cluster, upload that R file to the cluster, and run it on there. And don't hog all your computer resources. You can also do it interactively, right? I have no... There's no fault in like going in and like logging on to R and then doing all your interactive work here, right? Just like .r, I'm doing stuff, right? I'm sending stuff, right? I'm loading packages, I'm working interactively. There's no problem with that either. It's just when you want to send something and just have it run without having any user interaction, and sometimes you want to send like thousands and thousands of things, then it's very important that you know how to use a computing cluster. All right. So my suggestion, in the next half hour, I will send you this right now. In the next half hour, I would just take 5 minutes and read what the actual problem is. So if you have any like, I don't think this is a good idea, I think this is going to be way too much, I have no idea what I'm supposed to be doing in this, you can talk to Jeff and ask Jeff. Okay? Like about this problem. I think that's a good use of the next like 20 minutes, especially if this is going to be your assignment, because there are what? I mean, although I say to use the email, I know a lot of you don't, you sometimes ask a lot of times a question in class, so there's what, like 6 class, like if we gave you 3 weeks, there'd be this class plus 6 other ones or 5 other ones that you'd actually have face-to-face time with Jeff. So I would just figure out if I have questions. All right, so that is like a crash course from hell on the cluster. But at the end of the day, I'm just saying a lot of things seem like they're, oh, well, I just qsub, I make a .sh file, I already can do that. Just some of these things can make your workflow a lot faster, a lot easier. Especially those R batch and R no save one. I don't use qsub or qrsh anymore if I'm submitting R files. So just yeah, hopefully that's helpful. Always name your jobs, these kind of things. But again, this data is technically big, like small enough to put on your local machine. But I would use this not only as an exercise in machine learning, but just trying to get yourself up on the cluster. If you spend like 10 hours not understanding anything going on in the cluster, ask someone. It's the same thing as R, just on another machine. But I'm saying this is, I think, a good thing to do, because then on your CV and your resume, you should be like, I've worked on a high performance computing cluster. And if you're trying to be a data scientist, people are looking for that. Okay.